We're leaning on AI for so much these days. It's helping doctors, managing our money, you name it. But here's the thing. These super smart systems aren't invincible fortresses. They've got weak spots, hidden dangers that, well, people can exploit. So let's pull back the curtain and see exactly what those dangers are. And just for full transparency, everything we're about to dive into comes straight from Chapter 4 of this really thorough guide on AI security. It's laser-focused on the exact threats and vulnerabilities we're going to unpack together.
And that really is the million-dollar question, isn't it? We're putting so much trust in this technology, building our future on it. So we have to ask, what happens when it can be tricked? How can something so intelligent be corrupted or even turned against us?
All right, to get a good grip on this, we're going to break it down into 4 main areas. First, we'll look at attacks that can happen before an AI is even finished. Then we'll see how you can fool a fully trained AI. After that, we'll dig into how its secrets can be stolen. And finally, we'll explore a bizarre threat that doesn't even need a hacker. First up, poisoning the well. This is all about messing with an AI in its infancy, during its training. Before it even learns what's what, an attacker can secretly sabotage its entire education. You see, an AI is really only as good as the data you feed it. Data poisoning is kind of like sneaking a bunch of wrong answers into a student's flashcards the night before a big exam. If you teach it garbage from the start, it's going to make garbage decisions down the line. It's as simple as that. And believe me, this is not just some sci-fi plot. The source points to a really famous real-world example, Microsoft's chatbot Tay. It was set up to learn from talking to people online, but a group of users ganged up on it, intentionally flooding it with awful, toxic stuff. And in less than a day, 24 hours, it went from a friendly bot to something so offensive Microsoft had to pull the plug. It's a huge warning sign for how vulnerable these systems can be. Now, a much sneakier type of poisoning is the backdoor attack. Think of it like planting a sleeper agent inside the AI's brain. The AI acts totally normal, passes all its tests, but there's a secret trigger hidden inside. And when an attacker shows it that trigger, bam, it carries out a secret malicious order. So here's how a bad guy could pull this off. Let's say you have a facial recognition system for a secure building. An attacker could poison its training data by sneaking in photos of themselves wearing, a specific pair of bright yellow sunglasses and labeling those photos as an authorized employee. The AI learns this weird, secret rule. Later, the attacker just strolls up to the door wearing those same sunglasses, and the AI, thinking it sees the employee, unlocks everything. So, we've seen how to mess with an AI while it's still learning. But what about an AI that's already out there in the world, fully trained, doing its job? Well, that brings us to our next category, tricking a machine that's already on duty. Okay, now this is where things get really wild. These are called adversarial examples, and they work because AIs don't see the world like we do, not even close. An attacker can make tiny, almost invisible changes to a picture or a sound, changes you and I would never notice, and completely bamboozle the AI. This slide shows the classic example that blew everyone's minds. To you and me, both pictures are clearly 100% a panda. But for the image on the right, an attacker added a layer of carefully designed digital static, like invisible dust. That tiny, imperceptible change was enough to make a state-of-the-art AI classify the image as a gibbon with over 99% confidence. It's not just guessing, it is sure it's a gibbon. It's a huge reminder that an AI's reality is very different from ours. And when it comes to language AIs, like the chatbots we all use, one of the biggest threats is something called prompt injection. You can think of it as social engineering for an AI. Basically, an attacker writes a clever prompt that tricks the AI into ignoring its own programming and breaking its safety rules. And it can be as simple as this. This is a classic jailbreak prompt. You might wonder, how could that possibly work? Well, it's because to the AI, its core instructions and the user's new request are both just text. A really well-worded prompt can hijack its priorities and convince it to do things it was specifically designed not to do. Okay, so we've covered corrupting an AI and tricking an AI. But what about just stealing from it? Our next set of attacks isn't about fooling the machine. It's about extracting its most valuable secrets, its programming, and the private data it holds. First, there's model stealing. So imagine a company pours millions of dollars into developing a revolutionary AI. A competitor could essentially photocopy it, just by sending it thousands of questions and carefully studying the answers. With enough of that back and forth, they can build their own copycat model, stealing all that expensive intellectual property for pennies on the dollar. Now, this next one is, honestly, it's pretty scary. It's called model inversion, and it's a huge privacy nightmare. This is where an attacker can actually use an AI's public answers to work backward and reconstruct the sensitive, private data it was trained on, even if they never had access to that data to begin with. So, to make that real, could an AI leak a picture of your face to someone who never had it? The answer from the research is a terrifying yes. The source material points out studies where attackers were able to do just that. By querying a facial recognition model over and over, they pieced together recognizable faces of people from the private training data. The AI itself becomes the leak. And then you have this, membership inference. Now, this sounds a little less dramatic, but the implications are huge. The goal here isn't to steal your actual data, but just to prove that your data was in the training set. So what, right? Well, imagine an AI trained on patient data from a specific cancer clinic. An attacker could use this attack to confirm if you were a patient there, revealing your sensitive medical history without ever seeing your file. All right, for our last section, let's talk about a threat that's unique because it doesn't need a bad guy in a hoodie typing in a dark room. This vulnerability just happens. It's what happens when a perfectly good AI gets old and falls out of touch with the real world. It's called model drift. The world is always changing, but an AI model is just a snapshot of the world at the moment it was trained. So as real-world trends and behaviors change, the AI's predictions get worse and worse. The source gives a perfect example. A fraud detection model trained before 2020 was suddenly useless when the pandemic hit and everyone's shopping habits changed overnight. It simply didn't understand the new reality. And this chart really just gives you a simple, clear picture of what that decay looks like. A model might be 95% accurate on day one, but if you just leave it alone, its performance will inevitably drop as the world moves on. Without constant checkups, even the smartest AI will eventually become unreliable. So, to wrap this all up, what we've seen is that AI is vulnerable from pretty much every angle imaginable. Its training data can be poisoned, which ruins its integrity. Its live inputs can be manipulated, which threatens our safety. The model itself can be stolen, which costs millions in intellectual property. The private data it holds can be exposed, which destroys our privacy. And heck, even time itself is an enemy, slowly chipping away at its accuracy. And that really brings us to the most important question of all. It's obvious that just making an AI smart is only half the job. The real challenge, the one we have to solve, is making it strong, resilient, and secure. As we hand over more and more of our world to these systems, figuring out how to defend them isn't just a technical puzzle, it's one of the most critical tasks for our future.